Okay, we have 10 to the x equals 6. We want to rewrite this using logs and then solve. So how do I do this? Log base. What is the base? The base of the log is the base of the exponential expression, 10. The exponent goes on the other side. So log base 10 of something equals 6. Log base 10 of what equals, log base 10 of something equals x. It's log base 10 of 6 because, again, 10 to the 6 equals x. It's a little easier looking at it that other way, right? 10 is the base. X is the exponent. 10 to the x equals 6. We want to go ahead and think about that going the other way. Now, if I have log base 10, I don't need to write the 10. So log base 10 of 6 is the same as log of 6 equals x. So let's go ahead and look at that on the graphing calculator. So I want log, which is here. If you see log without a number, that's log base 10. Log of 6 gives me what? Gives me 0.77815. That's approximately what I have here, right? So x is approximately 0.77815. Now let's check that on the calculator just to make sure. Remember, we're solving 10 to the x equals 6. What is 10 to the 0.77815? 10 to the 0.77815 should be pretty close to 6. Is it? Pretty close to 6. And I could have added a few more decimal points and I would have gotten it even closer. So the next thing I want to look at is the following, is e to the x equals 7. And I want to rewrite that using logs and then get myself a decimal approximation. So log base what? The base here is the base of the logarithms. That's log base e. The exponent's on the right side. So that's e to the x equals what? Equals 7. Log base e of 7 equals x. But what is log base e? Log base e is known as the natural log. So natural log of 7 equals x. So let's get that from the graphing calculator. What is the natural log of 7? And we get 1.9459. So I'm going to check it. E to the 1.9459 should be pretty close to 7. Let's see if it is. E to the 1.9459. Do I get a number pretty close to 7? And I do. And if I added a few more decimal places, it would be even better. And the last question that I have here to work on is 5 to the x equals -2. Now, if we do it the same way I've done the others, I take log base what? Log base 5. The exponent's on the other side. 5 to the x equals -2. And right away, that makes me nervous because the argument of the log function has to be a positive number. Cannot be negative, cannot be 0. So right away, I think this isn't going to have a solution. Now, how can I convince myself of that? Let's take a look at the graph. Let's jump to Desmos now, if I can. So we're going to take a look at the graph here. I want to solve 5 to the x equals -2. So here's the graph of y equals 5 to the x. When does this equal -2? Here's y equals -2. When does this green graph intersect at -2? It never does. It never does. Therefore, what's my conclusion on this? No solution. 5 to the x is never negative 2, but if you think visually, you can convince yourself why that must be the case.